All right. Well, we welcome everybody to today's system spacing call. We're pleased to have a great topic lined up for today. Our topic is network troubleshooting techniques and approaches. And we're pleased to have Eli Dart from ESNet and Brenna Mead from Epic here to present on this for us. We reached out to them and kind of asked them to help us with what would be actually quite a challenging topic to throw at anybody. But just taking this topic from the sense that all of us run into challenges kind of at site to site, institution to institution level network problems once in a while. And just as much as each of those situations proves to be a very unique set of circumstances, the solution also proves to be equally as, individual and unique. So we approach these two kind of asking if they can kind of help us look at practical ways to approach these problems so we can be more effective. So with that, we'd kind of like to turn the time over to both Eli and Brenna and let you guys kind of indicate how things should go. Maybe one question I'd ask the two of you to indicate is how you'd like to handle questions, whether you'd like us to throw them at you as we go or to hold them for better times.
So hello, everyone. On the questions topic, at least from my portion, I'm going to leave it up to the questioner. So if there's something that's like relevant to that slide or whatever, feel free to jump in. You don't have to try to use raise hands or anything like that. Just unmute and interrupt. That's totally fine. For longer discussion topics, I'd say let's hold those to the end. But if there's something that's like relevant to the point at hand, just jump in. Brenna, does that work for you from your perspective?
Yes, absolutely. That sounds like a good plan to me. So
okay,
let's do it.
Okay, so my name's Eli Dart. I work for ESNet in the Science Engagement Group. Brenna, you want to introduce yourself real quick before we do slides?
Hi, everyone. My name is Brenna Mead. I work for Indiana University International Networks and also Epic. I'm also the SC21 WAN team lead for any of you guys going to SC, so I wear a variety of hats this year. I'm the newest employee there, so if there are any questions that I cannot answer, I will follow back up with you via email. It'll be a good opportunity for me to get to answer those questions for you as well. So thank you, Eli.
Awesome. Okay, so I will start slide land. So let's see here. That's not the right hotkey sequence now, is it? That is. As Brian mentioned, we're going to talk a little bit about techniques and approaches for network-based troubleshooting. This is a rough outline of my portion of the talk. So I'm going to go through a set of slides, and then I'm going to turn it over to Brenna for hers. So there's several different pieces to this. So I'm going to try to provide some background first, and then some more like case study discussions that talk through the ideas. But I want to say sort of at the outset, right, this is not a here's how you run perf to accomplish a specific task, right? So there's no like command syntax or perf output or things like that in this talk. There's already a bunch of really good material out there in the community that covers those things. I didn't want to sort of try to recreate that. And especially, in fact, there's a bunch of really good material in the context of Epic for that. There's a bunch of really good perf training stuff, routing stuff, other things. NSRC also has some good material too. So this is not a here's how you type these commands talk. So long distance troubleshooting stuff takes place right in the context of the wider network outside of our institutions, right? So what is that? That's the internet, right? Okay, so everybody knows what the internet is, right? And I just want to make a couple of points here that are going to turn out to be relevant for reasoning about troubleshooting. So yes, the internet's composed of a whole bunch of individual networks that are interconnected together. That's why it's called the internet. That's fine. all of the entities that build and operate those networks do so for their own reasons, and they connect those networks to each other, or maybe they don't, for their own reasons, right? And we've figured out over a long period of time, right, network effects, right? Networks are more valuable when they're connected to each other, but though that connectivity happens for selfish reasons, and the networks that are interconnected to form the internet are each built for selfish reasons, right? There's a reason somebody's paying to stand up a bunch of routers, stand up a bunch of switches, optical gear, trench some fiber, right, and operate all this stuff. And so if you look at these different things, right, all the stuff that's sort of green tinged there is kind of like the commercial world, and all the stuff that's blue tinged is the R&E or scientific world. And there's a bunch of these things that are interconnected to each other. And this is, you know, a simplified cartoon, but the point here, so let's look at AT&T and Google, right? So what does Google actually do, right? They run a bunch of big data centers, and they provide a bunch of services in those data centers. Those things are absolutely useless without users to connect to them. And so for Google's selfish reasons, they need connectivity to the other networks that will provide them with access to users, or more importantly, provide users with access to their stuff, right? Without Google's connections to other ISPs, to AT&T or whatever, Google ceases to exist as a valuable entity. Now for AT&T, what do, right? They provide last mile, all kinds of stuff, among other things, right? Again, this is a simplification, but if I was to sell you an AT&T phone that couldn't get to useful content, right, there'd be no point in that. So in order for the basic business value proposition for AT&T to exist, they have to be connected to these other entities, right? Google and others. So, you know, that's a drastic simplification. I would encourage people to go to CADA and browse through some of their visualization. It's like really cool stuff. You can easily burn a half an hour in that. But the key point here is there are selfish reasons for the existence of networks, the services they provide, and the engineering that goes into them. And those reasons cast a long shadow on the policies that govern that network, how reliable it is, how it's engineered and built, right? And I tell you what, networks are built differently. And that turns out to be important when we start trying to reason about their behavior in the context of performance engineering. So, okay, so there's all these different networks that make up the internet. I always start with traceroute when somebody comes to me. And, you know, this isn't a hard and fast rule. You don't have to do that, right? But I always find that, again, when I'm trying to get all this into my head, the first thing I want to figure out is who's talking to who and how are they getting there? And one of the things that's going to tell you immediately is the set of entities that I might have to deal with in working through whatever this is. And I want to point out, each direction has to be reasoned about separately. I mean, one hopes that the path is symmetric because it's a lot easier to think about in that way. But I've run into several circumstances where the path is wildly asymmetric. And Perf-Sonar is helpful at determining which, you know, how each direction behaves, even if you only have access to one end. But one of the first questions is, hey, is this going over R&E as it should, or is this going over commodity? And we've seen some shops that are losing their BGP expertise, right? So some old timer set all this routing stuff up, and then we do a hardware upgrade after they retire, and nobody really understands all this BGP policy goop that's in there, and so it doesn't really get recreated. And you throw all the routes in one bucket and let BGP path selection algorithms sort it out, what you'll find is that the R&E path may have more bandwidth, but it's got a longer AS path. BGP is a path vector protocol. So what's it going to do? It's going to choose the shortest AS path. So we've had major institutions talking to each other over their backup commodity provider rather than their super nice fast 100 gig R&E path, just because they hadn't put the BGP policy in place to prefer the high performance path. So another thing to remember is that there are exchange points that are often present at the interconnection between two different networks. And what that means specifically is you can just think about it as a big switch. In some cases, it's literally a switch. In other cases, it's a network of switches, depending on the scale of the exchange point. But if ESNet has a 100 gig port facing Manland, for example, right? So Manhattan Landing, it's an RNA exchange point in New York City. We can now talk to anyone else who has a port plugged into that switch. And so there's usually a peering VLAN there. Sometimes it's point-to-point VLANs. But what you end up with is a lot of interconnection going across this one interface that's plugged into an exchange point switch. Okay, that's great. Doesn't show up in a traceroute. And so what that means is that there's another entity in the path that you can't see. And it's usually not a problem, but sometimes it is. Also, those interfaces are places where a lot of fan-in can happen. And so you can get burst loss there if if either your router interface or the exchange point switch is inadequately buffered. So what are some common problems? We've all seen sort of poor tuning leading to poor performance. At this point, enough people use faster data that that's less of a problem than it used to be. But mistakes happen, and that's okay. If you're dealing with TCP, it's pretty easy to find, because what you'll see is on a loss-free path, right? So there's no packet loss involved, but performance scales. Performance is inversely proportional to latency, right? And so all that means is you're window limited, and so the farther away you get, the lower the performance is. And so that's pretty easy to spot. And the nice thing is the fix is pretty easy too. It's like, hey, go grab the right tuning parameters, drop them in syscontrol.conf, and you're good to go, right? I already talked about the routing problems for commodity versus RNE. Going over commodity can really be limiting. There were a couple of different, I don't have the links here, but there were a couple of folks a couple of years ago that did some testing over commodity paths, and high performance data transfers looked enough like their denial of service signature that they just blocked them in an automated way. It was pretty entertaining. So another set of issues is involved in tool choice. Some things it's easy to fix, right? Just can you use Globus or Ispera or whatever the data portal you need, or the HPC facility you need, or whatever the institution has a license for, or whatever. In other cases, it's impossible, right? Now, there's some gray area in between, but in some environments, it's like, no, it's SSH or you don't connect to this thing, or this data portal supports in-browser HTTP or nothing at all. And so you either have to like write a script to bot it or go clicky. Those are reducing in number, but some of them are there, and that gets harder. And I would encourage, if you run into something like that, especially with a data portal, I would encourage you to talk to either ESNet or Epic or both, depending on the environment. Other problems around not having a science DMZ. We've seen folks where I want to especially talk about prevented either by policy or by process. So we've seen examples where the security folks just say no, and especially in sensitive data environments, it's often the case. But also, I can think of at least one institution, which is not present here and will not be named, where they really want to do this, and their internal processes are such that the organization itself is incapable of doing it. And if you find yourself in the middle of one of those, I'm sorry, it's challenging, but sometimes it's actually not solvable, which is really unfortunate. And then, of course, our old friend packet loss, which I'll talk about here. So everyone's seen this graph. I'm not gonna go through it. If you haven't seen it, go dig around the Science DMZ content. You'll find this plot. The key point here is that at short distances, packet loss doesn't have near the impact on performance that it does over long distances, and that has some implications for testing methodology. So just remember that. I'll get back to that in a minute. So I mentioned fan-in before. So this is where you have multiple ingress flows from multiple switch ports destined for a common egress. And if that common egress is inadequately buffered, you can end up with congestion on microsecond timescales, and that'll cause you packet loss, even if the average throughput on 30-second timescales is not enough to saturate stuff. So in terms of sort of how much buffer is adequate, there's a nice NANOG paper that Michael Smitosson and Brian Tierney did a few years ago that characterizes that. It turns out like, and they came up with a lower number than I would have thought, actually. It's about 50 milliseconds at interface wire speed. Another thing that trips a lot of folks up is a speed change. So if you have a 10 gig host plugged into a shallow buffered switch that has 100 gig to the rest of the world, you could very well see packet loss at that very last hop. And I'll jump to the, well, so dirty fiber failing optics, we've all seen those. For the end host config, sometimes it's difficult to distinguish between the behavior of the last hop switch and the behavior of the host itself. So there's some nuance there. If your NIC isn't configured correctly, or you don't have enough, I forget the syscontrol in this moment, but it's the kernel receive buffer. If those are being overrun, you'll be getting packet loss at the host. If it's a speed step down at the first hop switch, right, then looking at the host isn't going to help you. And so the thing to remember is if you've got a 10 gig host, right, that means it's plugged into a 10 gig switch interface, even if that switch has 100 gig connectivity to everything else. And so the speed change actually happens on the switch, not on the host. So let's see. So how do we, taking all this stuff, right? How do we then approach a WAN performance problem? So again, I like to start with topology. Who's talking to who? What's talking to what? And how does each direction behave? One of the things that's challenging is that often DTNs don't have all the PerSonar kit installed on them. And really, they kind of shouldn't, because they're not PerSonar boxes, they're DTNs. And really, if you have like a data portal or something like that, the DTNs probably don't even have shells on them for anyone who doesn't have root. And so you're not necessarily going to be able to test with the DTN itself. So you need to find a PerSonar host near the DTN. And to find a PerSonar host near the DTN, there's the PerSonar directory there. I just go to stats.es.net. It's one of the links on that page. It's just, I find stats.es.net is easy to type. But if the problem isn't like really easy to solve, it's not just obvious what's going on, I find that it gets pretty important pretty quickly to have what I call a pedantically accurate map. And that's spend the time and draw the thing out. Draw out every connection in the path, not the whole network, but every connection in the path, and every organization in the path. We've literally found routers that people thought they had deployed. There was some organization, again, names redacted. Somebody had some Juniper MX that they thought they decommissioned 5 years prior, and it was still sitting there forwarding traffic. And they didn't realize that it was there until they went and actually did a port audit to find out what was actually connected to what in the process of building the map that we asked them to build. One thing is that if your DTN and PerSonar results are dramatically different, it may be that the problem is really close to the DTN on the portion of the path that is not common to the PerSonar box and the DTN. So that's another useful thing to keep in mind. So I'm going to walk through a real world example real quick here using PerSonar to debug something. I'm going to do this one in a little more detail, and then I'm going to talk through a couple of others that illustrate some of these points. So remember with the TCP loss plot, right? We were talking earlier about how packet loss doesn't have as much of a performance impact at low latencies as it does at longer latencies. So what this means for testing methodology is that if you just break the path down into segments and test across each segment, you may well miss the source of the problem because things are going to perform fairly well if those latencies are low. And even if you do see a little bit of loss, it'll recover, but also the TCP dynamics are going to be different, right? It's going to be differently bursty, much less bursty at lower latencies. And so it may very well be that it runs clean with a low latency flow and dirty with a high latency flow. And so really what we want to do is try to run long distance tests for as much of our troubleshooting exercise as we possibly can. So the way I like to deal with it is you pick an anchor point, as close to one end as is reasonable. Run the longest clean test that you can across the infrastructure, and then look for the shortest test that shows problems that also includes the entire path of the long clean test. And that increment, right, that step forward is a good indication of where to go look for a problem. It's useful to narrow this down to administrative domain as well as to devices, right? Because if the problem's in ESNet, it's not really a good use of anybody's time to go ask Internet 2 to check their interface counters, right? It's not going to find the thing. So the thing I will say though is you need to have Personar boxes deployed when you start doing this, right? We have Personar hosts deployed everywhere. Lots of other networks do. Most shops have at least one box somewhere. But there's a huge amount of productivity if the Personar boxes are already there, because you don't have to open a ticket with anybody. You can just go do it. If they're not there, now troubleshooting is gated on deployment, and that's a lot harder. So here's the problem statement, right? Here's what the user came to us with. I'm at a university. I'm trying to download some data from this lab, and performance is poor. Okay, so that's what they can see. So then Eli goes and runs a bunch of trace routes and builds a path. This is what the path actually looks like. So the vast majority of the latency involved is over the wide area, right? 30 milliseconds in ESNet, 15 in Internet 2, 2 milliseconds in the regional. The campuses are, add trivial amounts of latency to both. However, so let's go pick the farthest away ESNet Personar host from the end site as I can, and run some tests. So walk that test across the Personar hosts that are present in the network. And it turns out I can get all the way to the exit point of the regional, and it's all clean and it's all happy. So, okay, great. What that means is to first order, this portion of the path is unlikely to be the problem. When I reach forward into the university site, it was dirty, but only in one direction, right? The reverse direction was just fine. So, they were serving the data out that they needed to be serving out, and they weren't experiencing any problems. Great. It just so happens to be, ironically, that the direction that some other user needed, right, had some kind of issue in the path. And so what that means then is somewhere between the exit interface on the regional and the campus perimeter and the switching infrastructure, there's a problem, right? And so it turned out that there was a shallow buffer device just inside the campus perimeter, right? That's what this particular thing looked like. We've seen this sort of thing play out in a wide variety of circumstances, where a bunch of different players were the ones who were unlucky enough to have the device that was misbehaving. But that methodology turns out to be really powerful. So here's another example of using that methodology. And so this is my working diagram, and it's a little bit of an eye chart. I apologize. If you want to download the slides and look at it to read all the fine print, you can. This was a performance test, or a proof of concept verification, really, from a host for the Simons Observatory. I think it was actually in the Alma racks up in the Atacama Desert on the mountain in Chile, going down across Reuna, and then up Amlight to Miami, and then across ESNet back to our supercomputer center here in Berkeley at NERSC. And so what you're seeing here is after the troubleshooting exercise was done, the problem was in one of the switch stacks there in Santiago. And so we were working with, so Reuna was great in this. And so was Amlight. This is Julio Ibarra and Geronimo and those folks. Really great people to work with. And they were like, okay, well, we've got a way to give you this sort of temporary path to get around the switch stack. As soon as we did that, everything worked. And you can see, right, we're approaching 1 gig speeds from, and that host on the mountain was pretty underpowered, over 200 plus milliseconds, right? Almost 800 megs on a 1 gig path. Right, so it worked out really, really well, but it took a bunch of exactly this sort of methodology, right? So my anchor point was this NERSC perf sonar host, just trying to figure out which things talked to which things. Another one, this was from a long time ago, actually, back in almost 10 years ago. So there's a superconducting tokamak in South Korea that's doing some really important work in fusion energy. And what they wanted to do is take some of the data out of there, analyze it in near real time at a supercomputer center, either NERSC or at Oak Ridge, and turn the results of that analysis around to inform the ongoing experiment campaign. And so they had some performance requirements. We did a bunch of troubleshooting and testing. But again, it's the same sort of thing where you're reaching out progressively across the network, trying to figure out what's clean, what's dirty, right? And one of the problems that we had actually was the firewall that was there. It made it a lot harder to test to a perf sonar host in the facility itself. But fast forward a few years, there have actually been multiple papers published on this work in fusion journals. So, this ended up having a real impact. It's just this diagram is old enough now that there's a bunch of 10 gig interfaces in this thing. It's all 100 gig clean now. So this next one, so this was, ESNet's not involved in this at all, but we got called in to help because of our relationship with the LHC experiments. And just because they've been banging their heads on it and it was hard. So there's a particle physics site in Pakistan that was trying to get LHC data from Europe. And it was a bunch of stuff trying to figure out exactly what was going on. What we ended up learning was several very interesting things. So some places have peering politics. And so 2 countries in that region went to Singapore to peer, where the commodity providers were not so constrained. And so the latency was a lot higher on the RNE path. Also, you can see there's a 1 gig E for PERN to connect to Tain and therefore to Jaon. And so they were experiencing a lot of congestion. I mean, so we all talk about dirty fiber and failing optics and all this kind of stuff for causing packet loss. Well, it turns out if you flatline a link, it causes packet loss too, right? So like legit, for real, honest to goodness congestion definitely causes you packet loss problems. And so there's a take-home message here, right, which is that you got to resource your paths properly, and you may, in a troubleshooting exercise, end up in the middle of peering politics, and so that's just a fact of life, but it's something to be alert for. This is something that I and some supercomputer center folks did a few years ago. So this was to improve data transfer between DTNs. There was almost no wide area network troubleshooting involved in this thing. There was a little bit of network related stuff. A couple of the centers did some upgrades in the process, and I think we adjusted our peerings with NCSA as part of this. But the vast majority of the work was DTN tuning, file system tuning, right? So it turns out like the buffering parameters for GPFS, now spectrum scale, and luster are completely different. And so you can't say, oh, well, here's my GPFS tuning parameters, go stick them into your luster and have it all work. No, it doesn't work that way, unfortunately. And there were some significant implications for DTN host architecture that came out of this effort as well. But from a wide area network tuning perspective, there was almost nothing to do. And so this is a case where in the process of doing the work, we eliminated the wide area network as a source of the problem, but that still meant there was work to do and problems to solve. And so it ended up working with a lot of sysadmins and file system and storage groups to figure out what the challenges were and what needed to be fixed. So through all of this, so these are, I don't need to explain this to you, right? These are socio-technical endeavors. And one of the things that is the most important is that people are collaborative and willing to work together with each other. And so it's good to walk softly and it's good to be nice and polite. I know that seems kind of obvious, but it's easy, especially across cultural boundaries, to make mistakes. I have made this mistake multiple times, right? I consider myself to be fairly experienced at this stuff. I have made several important mistakes in this space. So do just, word to the wise, I got the scars to prove it. Be careful with this. And I will say that this culture of collaboration that the R&E community has is we should not underestimate the value of that spirit and culture of collaboration. As far as making those maps go, it can be difficult. I mean, you can't just ask for somebody to give you their map and have them give it to you. I mean, sure, ask, and you might get lucky, but in the general case, you won't. And the reason for that is the maps that most shops have are engineering diagrams, and they have stuff on them that they're not going to share with anybody outside the organization. So that means you're going to need to get good at drawing diagrams, right? And taking their input, right, from different folks and writing it all down. Something that I found too, and again, this is just, sociological game playing. There are plenty of folks who won't share, even if they say they will, they won't share anything with you. But if you send them something that's wrong, they'll correct you. And so it's often useful to just write up something that you know is wrong, send it out, and then you'll actually get the data that you want when people get grumpy that you sent out something wrong and decide they want to correct you. Another thing that I found is that giving people or wrangling access to a drawing or whatever is typically not all that productive. The thing I like to do is just tell people, print out the thing, sketch in whatever the improvements are, take a picture of it with your phone, send me the picture, and I'll just integrate the changes. That tends to go a lot faster. And then I guess the last thing is people will send you a traceroute even if they won't send you a map. And so, I can draw a map from traceroute. You can too. That is often the easiest way to get this done. So in terms of where to go for help or for collaboration, and I talked about the spirit of collaboration in this community before, and it's real. Most of us here in R&E are here because we believe in the work that we do, right? I'm personally here because of the science mission, right? And the positive effect on humanity that the research enterprise has. And we want that stuff to work and work well. And people who build infrastructure, they want their stuff to be useful for the purpose for which it's built. And so if you approach folks correctly, they'll generally be happy to work with you, right? Hey, can you please take a look because something's weird, right? Most people will be cool with that. And so don't be afraid to reach out to folks. It can sometimes be helpful to have a third party involved. And so depending on where what the space is. If it's in DOE land, talk to us at ESNet. So the engage address there is the science engagement group that I'm part of. Trouble@es.net is our NOC. So depending on what the nature of the issue is, you might talk to engagement. You might want to just say, hey, there's something down, or both. Whatever. In the university space, the EPIC Center does a really great job of helping out with issues that folks have in the community. So that's my point at which I'm going to hand it off to Brenna. And See, there's some stuff here in chat.
I think there's only one question, Eli, right at the bottom.
Oh, is there a generally accepted methodology for naming inter-router link addresses? No, it's awful. It's absolutely awful. All over the map. You're just going to have to infer. And in some cases, they're wrong too. We just had somebody, so we're in the middle of a network transition. So we're changing stuff from 10-year-old routers to brand new routers and so forth. And someone was like, hey, why is this still going through, X location? We're like, it's not. Well, your reverse DNS for your router interfaces says it is. So the reverse DNS for router interface addresses is actually a user-facing service. And so those of us who operate networks would do well to maintain it. But unfortunately, no, there are no standards at all. Sadly, it's just whatever it is, you're going to have to interpret it, sadly. So Brenna, it is all yours.
Great, let me get my presentation up here. Can everyone see my screen?
Yep, looks good.
So again, my name is Brenna Mead. I work for EPIC, Engagement and Performance Operations Center, pronounced EPIC, which I realize is sounds like it should be an I, but it isn't. And so this is a collaboration between ESNet and Indiana University International Networks. So the Engagement and Performance Operations Center, again, is like I said, a collaboration between Indiana University and ESNet, originally part of the CC Star program. So we got a 3.5 million over 3 years. And the goal is to create partnerships with regional infrastructure and science communities, both NSF and DOE, to create a better method of collaboration and to both deal with problems reactively and sort of going forward, trying to be proactive and discover problems before it becomes an issue that you have to come to EPIC for. So why EPIC? As Eli mentioned, science today is collaborative, and especially in the research, the R&E networks and this community, we love to collaborate, and the best science happens when you collaborate effectively. That means when you collaborate with science, there's multiple partners, many data sets, many point of contacts, and a fair amount of collaboration between multiple entities. And I think Eli sort of touched on this in his presentation as he was going through his troubleshooting, is that to troubleshoot these issues, you're talking to many NRENs, you're talking to a variety of scientists, or institutions, organizations. And so the goal of EPIC is to improve this collaboration and give you all a place to start and create these relationships. The 6 main focus areas are roadside assistance and consulting, application deep dives, network analysis through Netstage, data mobility, exhibition portal, provision of data managed services, and training. For this overview, I'm just going to focus on the first 3 areas because they tend to be our highest areas of collaboration. So roadside assistance, what is that? So this is, for example, when a scientist comes to us and says, last week, this file transferred fine, I had no issues, but it doesn't work anymore. This is like a flat tire on the road and you're calling the tow truck to come assist you to fix it. And so we, in that sense, are the tow truck. So you contact EPIC at iu.edu. Within 24 hours, we get triaged, we start to look into it with initial investigation and verify that there is actually an issue, and find the contacts that are best to start this collaboration and start to investigate this. The next step is a case manager and a lead engineer are assigned. I'm a network engineer by trade, so often I will be that lead engineer that you're assigned to help you with this triage and with your roadside assistance case. One of the first things we do is create an infrastructure to share effectively and make sure that all those permissions are right, so everyone involved in this collaboration can effectively access the data and the resources that we're using to try to solve this problem. So it sort of centralizes and gives these researchers and these network engineers at these campuses a single point of contact to centralize this assistance and help create these collaborations. The second area is called deep dives. So you'll notice that Epic really likes the car metaphors. So a deep dive is more like maintenance. So I need to get my oil changed. I'm planning to buy a new car. I need to do X, Y, and Z. So for deep dives, you come to Epic, and based on these requests, we review it. We walk through your network infrastructure, your storage infrastructure, whatever the scientists or the science workflow that these scientists are coming to us with. We go through that, and then we make recommendations after we try to understand your needs and what you're trying to do. This usually identifies, and Eli touched on this, issues that have nothing to do with the network. It's again, people, it's the sociology, it's the scientists. There's a disconnect between the scientists and the IT of the campus, or we're just not having the right people in the conversation to effectively either fix problems, troubleshoot, or improve performance. So a lot of what Epic does is try to identify those people, and really we try to be the bridge between those engineers and the scientists and help those people collaborate. So it's often less a network issue and more of a social issue and a people issue. So deep dives, the whole idea with a deep dive is to connect, again, the social aspect, the human beings with what they're trying to do with science, their machines, their applications, their science drivers. And so what Epic does is we bring together these researchers, these IT staffs, the administrators, and we try to discern their vision. What are they trying to do? What are the best ways to go forward with that vision? We share strategic plans, strategic initiatives. We go over your network technology teams and try to understand your organizational strategy so that we can, again, help bridge that gap. We serve as that interface between administration, technology, the scientists, research, and we try to help you all build these relationships or even identify the relationships that need to be built with these constituents within each organization, whether it's a university or an NREN or just whoever has reached out to us at that time. And of course, the end goal is to identify, resolve, or help improve network-related issues, performance issues that are existing or anticipated in 1, 3, 5 years as the universities grow, as their science initiatives change. So that is our goal, is to identify, resolve, and then recommend solutions for the future. So some of the expected outcomes from the deep dives is we try to identify technical gaps, bottlenecks, especially again, over that 1, 3, 5 year time period. If your science wants to grow, what does the network need to do to facilitate that growth and make sure that the performance is as expected and what those scientists need for continued operations. So we identify the opportunities that can be addressed with either new technology or existing technology that we can either adjust or just recommend changes to. Like I said, we help to forecast your technology and network capacity needs. And again, a lot of that comes from fostering these relationships with these researchers and getting these IT people, the administrators, and the researchers to all communicate in one forum and provide that consultation and that support within that realm of consulting. And then I touched a little bit on this earlier. Netstage is our way to attempt to be proactive. So the last two things I went over are very reactive. These scientists are coming to us with problems. These institutions are coming to us saying, we want to do X, Y, and Z over the next 5 years. And we'd like you to come do a deep dive and help us identify how to make that happen, or again, the bottlenecks or what the challenges will be in that period. So the goal of Netstage is actually to create measurement services for RNE data traffic so that we can have a better understanding of traffic patterns across all these RNE circuits. Eli touched on it. Asymmetrical routing is a huge problem within RNE networks, and it, as well as not taking the research and education route and instead taking the commodity route. So the goal of Netstage is to help us identify these problems so that we can go to you and say, hey, you're probably experiencing some performance issues on this link because, hey, your link is taking Lumen instead of your RNE link, and that's where your performance issue is. Or you have asymmetrical routing. So, you know, one way it goes, what would be the expected route, and then on the way back, it takes a completely different route that is that affects performance. So Netstage was initially an LSF program, and was a collaboration between Indiana University, LBNL, and University of Hawaii, Manoa. We do have international dashboards. We have partnerships with a variety of NRENs, internationally and domestic. And we are also now deploying these dashboards domestically. So for your campuses, for example, TAC or Learn, they've looked at domestic Netstage deployments. And other universities have come to us and said, hey, we're interested in in Netstage for our internal campus monitoring. So I do recommend you, if you're interested in Netstage and just taking a look, it's completely open. You can just go to the link here that I provided, and you can look at a variety of NRENs, international circuits, domestic circuits. I know for a fact that many of the research and education networks already have their own dashboards, such as the FRDP, Learn, as I mentioned. So this is a very cool area to go and look if you're just interested in seeing what's happening in the international or domestic community and how your transfers and your data is actually moving. So this we hope to grow and continue to be sort of proactive in helping people collaborate and helping people solve problems that they may not even know yet exist. For anyone who's interested in either a Roadside Assistance, deep dives, Netstage, or any of the other 3 areas of EPIC that you may want to look into, feel free to contact epic@iu.edu. And we will as I said, we'll respond usually within 24 hours and start to do some next steps with you as to you know, what your goals are and how we can help you. So if you're interested in more information about EPIC, I provided some links and some examples of deep dive reports that we've done. Those are pretty fascinating to read, or well, if you find network engineering and science drivers fascinating as I do. But so there's quite a few there for you to read. And then if anyone has any questions, I've provided my email. And if I cannot answer your question, I know at least 10 other people who can. And I'm happy to get any questions that you need answered. And we at EPIC are happy to help you with any of the 6 areas that you would like to engage with us about. And our entire goal is to help this research and education collaboration. So I believe that's the end of my presentation. Yes. Were there any questions?
I guess I throw out a quick one. You kind of talked about bringing everybody together into a common forum. Does that mean that there is some kind of online forum at this point where the community can start to kind of gather and, you know, share information, questions, et cetera?
Well, I mean, there's already a variety of forums for like research and education questions, et cetera. I think the goal of EPIC is more to bring those people together, whether in person or over virtual meetings, and actually speak with them directly. So it's less of a sort of web forum and more of trying to create, again, those sociological relationships and build those connections between actual people, so that within these roadside assistance cases or these deep dives, we can really create a place where everyone can come and get their questions answered and get the assistance that they need. We have a variety as EPIC of informational documents. If you go to the website, there's plenty of information for troubleshooting, et cetera. And many of the resources that Eli pointed to are faster data, ESNet. Those are all great resources as well, but we more want to be an in-person forum to bring real people together.
Okay, thank you.
So just an add-on to what Brenna said. It has been, in my experience, it has been difficult to get things like web-based forums actually up and to the point where the community actually uses them. The one success that I'm aware of is the CI engineering list that that my colleague Jason Zarowski. I mean, Jason's ESNet and Epic both, right? He, like Brenna, as you pointed out, right? We all wear lots of hats, right? But that is sort of the one of these that I think has stuck. So if folks are interested, it's just a mailing list, but there's relevant discussion sometimes. It's not super high traffic, and there's also announcements of the Friday CI lecture series, which is also useful. Depending on what the topic is this week, you may or may not find it interesting, but as a seminar series, it's been really, really valuable. Okay, Raj, let me find the link to that. I'll post it here as soon as I can find it.
Do we have any other questions at this time?
Okay, so I just dropped the link for the CI engineering seminar series, but there's also a link at the bottom of that page to sign up for the mailing list. But yeah, any other questions? And, you know, about anything, right? I mean, there's no stupid questions. You know, these are complicated things, and you know, it's funny. I was talking to Harvey Newman. I expect several of you know him. He's a big Caltech physicist, really senior leader in the LHC experiments. He said, you know, the thing I love about physics grad students, a physics grad student is okay with starting on a problem before they can see a clear path to the solution. And that's really a valuable intellectual approach to these sorts of things, because you know you're the solution simply isn't obvious, and the only way to deal with it is to just get in there and start writing down what you know, and you know, from there you'll figure it out. So anyway, other questions?
Feel free to unmute yourself or type a question in the chat.
And before everyone leaves the call, just a reminder, November's meeting, we're taking a break for November. We're all going, a group of us are going to see, I guess, hopefully virtually and in person.
So if anybody's still typing up a question, feel free to continue to do so. But while we're waiting, really appreciate all the time and effort Brenna and Eli have put into preparing this. This was great. Very insightful always to kind of see how these larger problems are approached, because they always appear to be quite the adventure to pull all the people together, and the emphasis given on the social aspect really seems to kind of put an exclamation point behind that importance. So thank you very much for putting the talk together.
You're most welcome. Thanks for the opportunity.
Yes, thank you. And for anyone who's interested, along with that CI Lunch and Learn Friday, I will be doing an overview of the SciNet SC21 network on December 3rd as part of that Lunch and Learn survey series. So if you guys get signed up to that list and are interested, December 3rd, after we take the network down and stuff, I'm going to do a whole overview of specifically the WAN network, but also of the full architecture. So if anyone's interested, go ahead and sign up for the CI list and we'll get you involved.
Yeah, I want to second that. So I did SciNet for 14 years. And I was always asked, do you want, budget for training or classes? I'm like, no, just send me there. Because it's really, I mean, that's the latest and greatest, whatever. And when, whether it's interoperability problems or wait, you mean you have to do what to configure what on this thing? Really? There's a lot of that sort of operational expertise that comes out of the SciNet effort. So it's really valuable either for you or for folks in your shop if you can't do it. But I would totally put in a plug for that.
All right. Well, thanks everybody for attending today, and thanks again for our presenters for the time and effort they put in. And with that, I guess we'll call today's done.
Thanks all.
Thanks, everyone.
Thank you.
Thanks, everyone.
Thank you.